Very good morning, students. Welcome to the another first video of online classes. I hope you all are fine and you all are doing your studies well. Okay, so today we'll have the physics chapter 4, refraction of light at plane surfaces. This one is the part 3 video. Earlier we have already discussed in the two videos about this chapter. Okay, so let us begin with the content. Which are the content in this chapter? Okay, so refraction of light you have already completed, and laws of refraction also completed. Speed of light in different media, that also we have completed, and principle of reversibility of the path of the light, and the experimental verification of law of refraction and determination of refractive index of glass. And the last topic is what? Refraction through a regular glass slab. Okay, in this video we'll have discussion on these three topics. Okay, so let us begin with the first topic, principle of reversibility of the path of the light. Okay, so here we'll have discussion. Let us start with the first point. Okay, so see the figure here. So there are two mediums, medium 1 and medium 2, and S dash separates the two mediums. Okay, and a ray of light passing from A to O, it is incidented at an angle I. This one is the angle I. Okay, angle I, and the plane surface separates S dash. Okay, this is the separating separating plane surface of two mediums 1 and medium 2. Okay, it refracted along OB. So when it passes from A to O, and it refracted through from O to B, and making an angle R with the normal. Okay, this one is the normal and this one is the refraction angle. Okay, so the refractive index of medium 2 with respect to medium 1 can be written as like this: 1 mu 2 is equal to mu 2 by mu 1 is equal to, we know that sin I by sin R, which is equal to V1 by V2. How we wrote this one, we already discussed in the previous video, part 2 video. You just, those who have doubt on that, just go through that video, part 2. And then now if the diffraction takes place from the medium 2 to 1, then the principle of reversibility requires that the ray of light incident along BO at O at an angle R in medium 2 will be refracted only along OA with making an angle I in medium 1. Okay, so the refractive index of the medium 1 with respect to medium 2 can be written as like this: 2 mu 1 is equal to mu 1 by mu 2, sin R by sin I is equal to V2 by V1. Okay, so here we have the two equations, and from equation 1 and 2, by multiplying these two, we will get sin I by sin R multiplied by sin R by sin I. So now here the sin I cancels with sin I, sin R cancels with sin R, then we will get 1. So mu 1 2 multiplied by mu 2 1 is equal to 1. Or also we can write mu 2 1 is equal to 1 by mu 1 2, or 1 mu 2 is equal to 1 by 2 mu 1. We can write like this. So the refractive index of glass with respect to air can be given by A mu G is equal to 3 by 2, because we know that 3 by 2, 3 is the speed of light, 3 into 10 to the power 8 is the speed of light in air, and 2 is the speed of 2 into 10 to the power 8 meter per second is the speed of light in a glass. Okay, so the refractive index of air with respect to glass can be written as 1 by 3 by 2, it will be 2 by 3. This is the reciprocal of A mu G. So A mu G is reciprocal of A G mu. Okay, so then we have the experimental verification of the laws of refraction and determination of refractive index of a glass. So this one is the experiment. Let us start with the procedures. Okay, first what we will do, we have to take a rectangular block is placed on a white sheet of paper fixed on drawing board, and its boundary lines P, Q, R, S is to be drawn by a pencil as shown in the figure. Okay, then what we will do, the block is removed, and on the boundary line PQ and point O is chosen nearly at its middle, and a normal NMO. See the normal here. This is the normal. Normal means perpendicular. So NMO. So this one is NOM. This one is the normal drawn at O. Then what you will do? On the line PQ will draw. Then the third point is what you will do, a line AO is drawn which is inclined at an angle I. Let us take 40 degree. So now here AO a line we drawn and making an angle 40 degree with the normal. Okay. Then the block is replaced exactly on its boundary. Now you replace the block on the place PQ RS. Okay, then two pins A and B are fixed here on the line AO. Then what you will do, looking from the other side S and R, what we will do, the block by keeping I on here, we have to place the pins pins C and D by making an we have to see from here this side RS, and make sure the 4 pins should be in a single line. Okay, then now the pins are removed and you have to draw a line BC here. Now the pins are removed from their place, then the block is removed from the end, and the points CD are joined by the line BC which meets the boundary RS at B. Then the point O and B are joined here. From here to here you join the point from O to B, joined by the straight line which gives the path of light ray inside the glass block. So how the ray of light goes inside the glass block? See, from A to O, then it is refracted through the glass slab. It is going from O to B like this, then B to C, again refracted out of the glass slab. Okay, so here AO represent the incident ray, this one is the incident ray, and OB is the refracted ray through the block, and BC is the emergent ray which is coming out from the block. Here NMO is the normal at the point O, and angle AON, this angle, and this angle is angle of incidence. Okay, and angle B, here you see BOM. So BOM, this is the angle of refraction. Okay, now then what you will do, then measure the angle I and R, read the values of sin I and sin R from the glass from the table, calculate the ratio of sin I by sin R, the given refractive index of the glass will get. Okay, by repeat this process, okay, by changing the incident angle from 40 to 30, 30 to 50, 60, 70 like this, we can calculate, we can find the ratio sin I by sin R. Okay, then or df by dg also we can calculate. Then what we will do, then make a tabulation of that. We can for 40 degree what is the refraction angle, what is the sin I, then sin R, then the ratio of those two. Then for 50 what is the refraction angle, then what is sin I, what is sin R, and then what is the value of mu sin I by sin R will calculate. Then the average then the average refractive index can be calculated from this tabulation. Okay, now from this we can calculate the refractive index of a material of that glass. Okay, then what we will do, the incident ray AO and the refracted ray OB are in the plane of paper. Okay, in the same plane. Okay, we have, this is the plane of paper, the incident angle, this is the normal, and this is the refracted ray. These all are lies on a same plane, which verifies the first law of refraction. Okay, so then we have a refraction through a rectangular glass slab. Okay, so this is also a glass block also we can say. Okay, see how the light is passing through a glass slab. You already know the mechanism how that the ray of light passing through a glass slab. Okay, so we'll elaborately see this method. So how it is passing from air to glass block, from then once again it is refracted through glass to air. Okay, so see this figure. So here there are two surfaces. This one is the air, this one is air outside the glass, and this one is the glass, and this one is also air. Okay, so now see here the incident ray SAO, where NOM is the normal on the side PQ, on the surface PQ, the incident angle is I here. So now it will be refracted as it passes from rarer to denser medium. It will be moves towards the normal. So the refracted angle here is what, R. Okay, then it passes through from O to B, then at surface SR at B it will again refracted, because of from glass to air it is refraction is then what will be, then it will pass through the line BC like that. So it will bend away from the normal because it is passing from denser to rarer medium. Okay, now you just draw this line AO and OB, then BC. Then what we will do, then simply we have to extend the AO, then we will get a line which meets at D. So this line will get AD line. Okay, see here, when the ray of light passing through a glass slab, then what will happen, there is a displacement of the incident ray. Okay, see this is the path of the incident ray without the glass slab, but when the glass slab is there, then it is passing through BC, then there is a displacement is there. This displacement is called as lateral displacement. Okay, so I will have I will give a link about this. So another video will you just see and just go through the video, then we will conclude this chapter. Okay, so thank you, have a nice day.